Hey, hi everyone. Thanks for coming to this session. I'm excited to hear about talk about more of like Go and WebAssembly and sort of like profiling WebAssembly applications. So this is the agenda for today. So we'll cover Go. So like we use Go every day, but maybe not everyone does. So we'll go into little bit of Go and like one slide, and then we'll jump into WebAssembly and how we use Go, using Go applications and other languages. Then we'll be going deep into the main topic like profiling WebAssembly applications and using wzprof. And then I will show you a little bit of demo, not demo, but more of like slide about profiling that application. So we'll be going into a CPU profiling and memory profiling. And finally, we'll talk about the future of WebAssembly and profiling using wzprof and other tools. So these are the agendas for today, this talk. So yeah, so my name is Rajiv. I originally from Bihar, India. I'm currently working as software engineer at AP Moller Maersk, a logistic company, in platform engineering team. So I'm located in Bangalore, India. I graduated 2 years back from JSS College, Bangalore. So I did BTech in Information Science Engineering. And yeah, so I started working with Go back in 2020. So I did participate in a program called Google Season of Docs. So the project was on gRPC Gateway. So I did contribution to this plugin. So yeah, I'm an open source enthusiast, and I did a lot of contributions to open source programs like Season of Docs, LFX mentorship, and Summer of Code. Currently, I'm mentoring for GShock 24 for Jenkins CI project. So this is done now because GShock is completed. So I did a lot of work on other companies, Lumo, Redbus in my college days. So I'm here to talk about Go, WebAssembly, and how we can profile WebAssembly applications using PProf and wzprof. Okay, so let's start with what is Go. So yeah, Go is a programming language. It was developed, I think, 2007 and released in 2009. And yeah, it is maintained by, it's open source project maintained by Google. I won't go deep into Go, but yeah, a little bit more stuff. It is a multi-paradigm programming language. So it's more like oriented towards developing highly secure and production quality applications. And yeah, Go is rich standard library and advanced stuff like concurrency and built-in language, concurrency built-in language. So we can have those concurrency stuff using channels, Go routines, sectors. And yeah, it's very portable. So it compiles to a multitude of targets, and it includes WebAssembly. So we can compile WebAssembly using, there are 2 ports. One is JS port, JavaScript port, and one is WASI P1 port. So WASI P1 is like a new port they have added in Golang 1.22 release. So we can compile these WebAssembly using 2 ports. We just have to define Goose and GoArch there. So when we compile those stuff. So the Go program is entry point of Go toolchain. So basically, it's how developers build and maintain their applications. And I said it provides a lot of standard tooling. So tooling, managing dependencies, formatting code, Go testing the code, and more advanced stuff like CPU, like built-in CPU profiling and memory profile. There is a lot of stuff about Go. These are the main stuff I wrote. So we'll be talking more of how this PProf is, how it is helping in profiling Go and other stuff. So yeah, profiling with PProf. So basically, performance profiling is a powerful tool for developers, and this history is back of 1970 in 80s days. So when first tool Prof was created, so it was created by Unix back in 80s and 70s. And I mean, tools like Linux Perf have provided powerful solutions back 2010, those times. But I mean, yet modern programming language like still lack of quality profiling tools and all. So I mean, but we need it, right? I mean, instrumenting observability is very crucial. We have to know are the bottlenecks of the programs, where the computational footprints are going, how much is taking time, and those stuff. That's how we make the things more optimized. We got to know the data and we work on that via some stuff. So it's very significant part. So basically, PProf is a tool for visualizing and analyzing profiling data. It's just a tool to do the stuff. I mean, the package PProf, so this is a package in Go, so serves like HTTP server runtime profiling data, and in the format expected by PProf visualization tool. So basically, it just serves the data in that format. And we can do like, can be used for CPU, profiling CPU, memory, and even for block profiling, Go routine profiling. So CPU and memory profiling is just profiling of CPUs and how much compute it's taking, and memory is like how much data, how much it holds objects and those stuff. Block profiling basically detects the Go routines, like where it is blocked, when we synchronize the stuff, where those things are blocked. So those things are profiled via block profiling. And yeah, I mean, Go routine profiling is if I want to know the state of the Go routine, where it is, so we do the Go routine profiling. And we do using flags. So when we do the profiling, we pass simple flags, command line flags to do the stuff, how we need the things, CPU profile or memory profile. Yeah, I mean, so this is about the profiling with PProf. So let's start with what is WebAssembly. Okay, so basically WebAssembly originally started browser technology, and I mean basically it is just a bytecode instructions for a virtual machine. So also referred as host or a runtime. So I'm referring here virtual machine is a stack-based virtual machine. So what I mean is stack-based virtual machine is just a simple word, like stack is a data structure and we store the stuff, and how like V8 engine is there, stack-based virtual machine. So for those stack-based virtual machine, we have a simple instruction code, and this is a bytecode. So this is basically WebAssembly is just sort of like compilation target. So, but also one more thing, like by default, like basically WebAssembly is just purely compute and memory. But the runtime can basically the runtime can expose function for guest model to import those are called like host functions. So we can import those things. Like in the recent time, like I mean, obviously WebAssembly is very new, and things are going on. A lot of things are going on in different languages, like merging it stuff. So we have a lot of standalone runtimes which is evolving. Like we have wzero, wasm time, wasm edge. These are the runtimes for WebAssembly, which is growing day by day. And yeah, I mean, while these runtime can use as in-run programs compiled to WebAssembly, and can also be embedded into existing applications. So for example, wzero is written, you can compile any languages to WebAssembly using wzero, but it is written in Go language. So we can use as a library too in a Go. So those things also we can do if that runtime is based on that language. Also, like for example, like you can write a plugin in Rust and compile it to WebAssembly and embed it to Go application. So it just act like a shared library. Yeah, so WebAssembly runtime also offer like fairly strong sandboxing thing. And in some cases, even allow running models from the untrusted sources. So we can do that too using WebAssembly. Yeah, I mean, like, however, for these capabilities to work, there is need a common interface. There is need some sort of like API, like standardization to do this, doing system calls, kernel calls. We need some standard stuff. So, like, we have like called WASI, called WebAssembly System Interface. So basically, WebAssembly comes under the W3C, and this is something WASI was obviously follow the W3C rules and all. So WebAssembly system interface is something we can do system calls, API calls, and those stuff. And also we can do like if I want to call some particular function from WebAssembly, basically importing, exporting. So we have like wasm import and wasm export. So basically, wasm import directive is used to import function from WebAssembly module, and wasm export directive is used to export the function from WebAssembly module. I said you like WebAssembly is very new, so different languages are working on this export import thing, like 64-bit should we follow, or 32. Like in Go, we have a lot of proposals adding this stuff. So it's growing. And yeah, WASI, I said you like in Go 122, we have WASI integration. So now we have WASI 2, what we say like component model or sort of thing. So in Go, we don't have that thing. In Tiny Go, we have that component model stuff. So this is like a little bit overview about WebAssembly. At a nutshell, it's just a simple binary instruction code for stack-based virtual machines. Yeah. So the main thing, the profiling. So we have WebAssembly application. There should be a thing to profile these application. How will you profile that? There is a lot of ways, and wzprof is a basically cross-language CPU and memory profiler for WebAssembly. So basically, it's just laying on the grounds of like sort of universal profiler. So it's making we are making that things like a universal profiler, so that it can be used for all the stuff related to WebAssembly. And yeah, I mean, this is open source project. So this is developed by Dispatch Run. So Dispatch Run is a company more of sort of like a workflow orchestration thing. And yeah, it's developed by these people. So, and yeah, internally it uses wzero as a runtime. So wzero is a zero dependency WebAssembly runtime and can run WebAssembly models on servers. So I said wzero is also open source project by Tetrate, and it's what they say is zero dependency. It doesn't depend on anything. We can compile any languages to WebAssembly. And yeah, I mean, I said it's written in Go, so we can use as a library too in the Go using modules. Yeah, so wzero is written in Go, but it's a WebAssembly runtime. It can run any WASM modules regardless of programming language from which module was built. So the wzprof is based on PProf data format and is cross-language profile. So we can basically bring the benefits of PProf to language like Rust or anything. So PProf is something in Go, so we can compile those things to a WebAssembly and then use that thing. So WebAssembly modules binary thing can be run in any other language. So we can use the PProf in Rust too. So that's a power of WebAssembly. Also, like because we used to expose these profiles, so we got memory profiles, CPU profiles via HTTP endpoints. So any continuous profiler like supporting PProf profiles is compatible to wzprof. So for example, we can use tools like Parka from Polar Signals or Pyroscope from Grafana Labs. So like we can use this continuous profiler to visualize those things. Also, maybe an interesting bit is that wzprof instrument all WASM functions calls. So basically, it captures the stack trace for all of them, and basically, in sort of like counts the stack trace and present that count in a more of like visual format, in a PProf format for a like maximal integration thing. And yeah, I mean the rest of the PProf ecosystem. So basically, it captures the stack traces, count it, and just visualize in a PProf format. Yeah, so we as of now we do using wzprof. We have two type of profiling. One is like CPU profiling, and other is like memory profiling. So let's talk about how wzprof does the CPU and memory profiling internally. So in v0 we have some sort of like called function listener, which instrument the execution of Azure modules. So what wzprof does is like wzprof instrument this execution of Azure modules and using the function listener facility in v0. So yeah, I mean it doesn't matter which language the Azure module was originally compiled from. At the end of the day, it's just WebAssembly bytecode, right? So I'm going to show like how we can just write a simple program, compile it to WebAssembly, and generate the CPU and memory profilers. So to generate the profile, you need to write a code, right? I mean, build it to WebAssembly, and then run wzprof command to the path where this WebAssembly binary is located. So this is something I wrote a hello world sort of thing in Go. And then I have built the Go code to WebAssembly. We can build any other language. Even Rust, we use some flags to run it. So I'm just using Go. So I said, there is a new port they have added, WASI P1. So Go is WASI P1 and Go arc wasm. And then we run the command go build, and it will generate a main.wasm binary, code. And then we have the main.wasm. We can profile that main.wasm using wzprof. It's very simple. So after the building, then we are just creating the CPU and memory profile. So we run the command like, also we can pass the samples, I'm just passing a one sample. Basically sample flag specify the number of samples takes per second. So we can have anything according to our need. So we generate our mem profile, and then we generate the CPU profile. So when you run this, we will be having those files in there. So now I want to visualize that we got that mem profile out and CPU profile. So now I want to visualize those stuff. So we just run PProf command and go tool PProf and that port where we want to expose these things. So here I'm just exposing the memory profile. So you can see the simple hello world program. It takes like 27 point something memory, and basically why we're seeing so much memory to 27 KB and all, is just a hello world thing, right? Basically what happened, like when we run this command, a lot of profiles are generated, extra things. So since I used Go, so when we compile the Go code, it doesn't come with the what code I have wrote, but extra runtimes. So Go runtime also compiled with WASM. So these memory profile, you can see these are also of Go runtimes. We cannot exclude the Go runtime. So that's why we are seeing a lot of stuff going here. So Go runtime is just more of Go code that runs same process as your code. So it's not separate process, but can be profiled independently. We can do it like starting, but I'm just saying like it's a Go runtime code, which your code, what I wrote, hello wzprof. So yeah, I mean, therefore we need to initialize the Go runtime to obtain the profile. So this is a memory profile, and same with the CPU profile. So Go tool, I've given the port where I want to expose it. And yeah, this is a CPU profile. So this is a flame graph I have used. This is a simple table graph type stuff. So this is a CPU profile, and here you can see the CPU profile like net poll, schedule, and main functions and all. So I said you write Go code comes with the runtime too. So that's why we are saying a lot of data here. But this we can like instrument it accordingly. What the main idea is like how we can visualize this data using PProf, and how we can generate the profilers using wzprof. Yeah, I mean future of profiling WebAssembly with wzprof. So there are a lot of things going on. I mean, since WebAssembly is only a new thing, but profiling is also very new. So wzprof is major step. They created this project bringing Go PProf power to other compiling languages. I mean, even EPPF also, there is a discussion going on, like, could profile be done in depth for guest through calls, host functions, down to kernel syscalls, and will this be a native profiler using prof, or EPPF will come into part of WebAssembly? These things, discussions are going on. I mean, there is a lot of things, a lot of exciting stuff, and these are many opportunity we are excited about as we continue to explore possibility unlock the stuff around WebAssembly. And also there was we are looking into how we enable profiling like interpreted languages like Python. So yeah, I mean that's sort of like the future, and there is a lot, like I just wrote the profiling related stuff. And yeah, that's it. Thank you so much for listening me, and we are happy to take any question if you have any. Thank you.
Any questions?
Hi, thank you very much for your talk. It was very interesting. If I understood correctly, you can, with this tool, then analyze code compiled to WASM from any programming language.
Like you were saying, like can we compile, like we can write the code and compile it to WASM and profile it? You were saying that? Yeah, we can do it, right? That's the power of wzprof. So like we have a code, right? Any language, maybe a Rust. I showed you Go code. We compile using their runtimes. Like I have used wzero. We can use wzero too. It can compile anything. Whenever you compile any language to WASM modules, at the end of the day, we have a WASM bytecode. That's it, platform independent. Even it's better than Docker too. Even Docker also, when we change the architecture, images should be in the same architecture. WASM is not on those things. It's totally isolated from OS and those things. So at the end of the day, we have a WASM modules. Then we can compile using wzprof. It doesn't matter.
Okay, thank you.
Yeah, thank you.
My question is surrounding continuous maybe profiling in a running application. Now you did all on the command line. But let's say we've deployed something in a Kubernetes cluster or something like that. Would that be more of a use case for Bailar, for example, or what would you suggest for that use case?
Oh, I think you're asking that how we can do continuous profiling of these things.
Yeah, or profiling which is not on the command line on your computer, for example.
Yeah, I mean, so basically I said you right. I mean, we can PProf generates HTTP endpoints. So it's just a endpoint running. So we can use any continuous profiler for that, right? Capturing those traces, Parka or something. I showed you then, I didn't show you the example, but we can use any continuous profiler to profile it, because at the end of the day, we have HTTP endpoints for that. So automatically it will be taking those stuff and showing the data there. Thank you.
Any other questions? One. Thank you very much.
Thank you so much, everyone. Thank you.